Hello ladies and gentlemen, today we're talking about section 3.4, which is finding and using slopes of lines. And we're going to talk a lot about parallel and perpendicular lines because that's kind of the center focus of the chapter we're in right now. And starting with this one, we're going to do a review of how we can find and calculate the slope of a line. And there's one of two methods we could use to do this. We're going to start with this problem with lines A, B, C, and D, starting with line A. If we're going to calculate the slope, if we're given a graph, there's a nice and quick, easy way we can calculate our slope. Well, for any slope, we calculate it by finding the rise over the run. One way we can calculate the rise and the run is to count units on our graph. We can choose any 2 points on our line. I'll choose the 2 points that they've labeled for us, although I could choose any 2 points I wanted to. I'm going to count my rise and my run. Just like reading a book or anything in English class, you're going to read something from left to right. I'm going to start with a point that's on my left and then go over to my right. My rise is how I change and move up and down. So I'm going to move from first point to second point. I'm moving down 2 units. I do this perfectly vertical. So my rise is going to be -2 because I'm moving down 2. To find my run, I'm going to see how I'm moving left to right. In this case, I'm moving right 2 units. And since I'm moving to the right, it's positive. If I were moving to the left, it would be negative. So my slope is -2 over 2. We always reduce our fractions, so our slope ends up being -1. Our line is moving down from left to right as we read it, so it should have a negative slope, which it does. It's -1. The second way you could find your slope, or your rise over your run, is to use your slope formula, especially if you're not given a graph. That looks like y2 minus y1 for your rise, and x2 minus x1 for your run. What you would do is take, again, 2 points. In this case, I'll take the 2 points that are labeled for me. So choosing those 2 points, I have coordinate pairs that are given with those, and I'm going to use my x1, y1, x2, y2 set up here. That should be a 1, not a 2. And plugging those into my slope formula, for my y2 minus y1, it's 2 minus 4. And for my x2 minus x1, it's 8 minus 6. And if I simplify these, 2 minus 4 is -2, 8 minus 6 is 2, the same as I got just by counting. And again, it reduces to -1. So either way, your slope for line A is -1. Whether you count your rise over your run, or you use your slope formula to find your rise over your run. Either way, it's -1. And let's calculate the slope of our other 3 lines. So again, we're finding the rise over the run for all of them. We know that A is -1. For B, let's do a different color here. For B, since we're given the graph, I'm going to do the counting method for rise over run. So B is my green line. I'm given 2 points, so I'm going to count my rise, which in this case going from left to right. I'm moving up, so up 1, 2, 3, 4. So my rise is going to be +4 since I'm moving up. My run is 2, 1, 2. Since I'm moving right 2, it's +2. So my slope is 2 for line B. For line C, I'm also given 2 points. Let me erase what I have here for line B. For line C, I'm given, again, a common point 6, 4, and the other point 0, 4. Well, if I'm counting my rise for line C, I'm not moving up at all or down at all between my 2 points. So my rise is going to be 0. If I'm moving right, 1, 2, 3, 4, 5, 6 here. So if I just choose 2 points, I notice that my slope is 0 over 6, or just 0. For any horizontal line, there is never any never any rise. We're never moving up or down at all. So in this case, any horizontal line will be a slope of 0. So again, a horizontal line is always 0. Hopefully this is looking familiar. For D, if I count my rise over my run, for my 2 points, my common point, my point down here, this time I am rising. I'm going up 1, 2, 3, 4. But I'm not moving left or right at all. So I don't really have a run here, so my denominator is 0. But the problem here is we can't divide by 0. Even if you test this in a calculator, your calculator will send back an error message to you. It's impossible to divide by 0, so we call this an undefined slope. So anytime you have a vertical line, its slope is undefined. Nice little review of slope. Talking about parallel and perpendicular lines now, we've done a little review of slope. The slope of parallel lines always have a special property. This is postulate 17. Their slopes are always the same. Always the exact same numbers. So two lines always have the same slope if they're parallel. If they're perpendicular, their slopes have a special relationship. It's different. If we were ever to multiply our two slopes together, our product would be -1. The better way to look at this, though, that I've found is that the slopes are opposite reciprocals. So for example, if I said that one slope was positive 1 over 2, the perpendicular slope, we would turn that positive to a negative, and instead of 1 over 2, it would be 2 over 1. So you take the reciprocal, you flip your fraction, and your opposite, you just change the sign. So again, parallel lines are always the same slope, perpendicular lines always are opposite reciprocals. So we're going to find the slope of each line and see which one is parallel. These are lines k sub 1, k sub 2, and k sub 3. And if we count the rise over the run in k sub 1, we're moving up 1, 2, 3, 4. So our rise is 4. And moving to the right 1, so our run is 1. So our slope is 4 over 1, or just 4. Looking at k sub 2, choosing the 2 points, again from left to right, we're moving up 1, 2, 3, 4, and right 1. So again, it's positive 4 over positive 1, or 4. And for our last line, we're going to count our 2 points, rise over run, 1, 2, 3, 4, 5, and right 1. So our slope is 5. So if we were to choose two lines that are parallel, although they all appear to be parallel when we look at them in the picture, the only two that actually are parallel are K1 is parallel to K2 because they have the same slope. Again, K2 and K3 look like they're parallel, but they're not because K3 has a slightly different slope. So if we were to extend these and continue these on, you'd probably see them getting closer and closer together and eventually intersecting, probably somewhere way above where the screen would show. Skip that one for now. For example 3, drawing a perpendicular line, there's a few steps we have to take here. The directions say line H passes through 3, 0 and 7, 6. Graph the line perpendicular to H and that passes through the point 2, 5. Well, if we're going to graph this, we know we need 2 points to graph it. One point they give us, 2, 5. So go right 2 and up 5. We need to find a second point. To find a second point, we need to use our slope. So we need to find our perpendicular slope. So first we have to find our original slope, and then find the slope perpendicular to it. So our original slope, we're given these set of points, and since we don't have a graph, we'll use our slope formula, x1, y1, x2, and y2, which looks like y2 minus y1 over x2 minus x1. And for y2 minus y1, this will be 6 minus 0 over 7 minus 3, which ends up giving us 6 over 4, which reduces to 3/2. So our original slope is 3/2. But we're looking for the line that's perpendicular to our original line. So we need to find our perpendicular slope. So we take the opposite reciprocal. So instead of positive 3 over 2, it's going to be negative 2 over 3. And m, remember, represents slope. And we'll plot our new point, our second point, using the slope. So we're going to use our slope. So point number 2. Since our slope is negative 2, positive 3, we're going to move down 2 and right 3. Starting from the point we were given. We're going to move down, down 2, 1, 2, and right 3, 1, 2, 3. There's our new point, so now we can draw the line. Now it doesn't say we had to graph the original line, but just to show you that they are perpendicular, I'm going to graph the first one. So that's 3, 0 and 7, 6. Let's say that's it. 1, 2, 3, 4, 5, 6, 7, yeah. And if I were to graph those two lines, they do appear to be perpendicular. They appear to form a right angle here. Again, you didn't have to draw the original one, just the new one. So you find your original slope, convert that to your perpendicular slope, and then use that with your first point to find your second point. And last example, line N passes through those two given points, and line M passes through the other two. Are they perpendicular? Well, let's find the both slopes and see if they multiply to give us -1, or more simply, if they're opposite reciprocals. So for line N, we're going to find our slope. The slope of line N, using our slope formula, y2 minus y1 over x2 minus x1, and I'll label my points. 5 minus 2 for the y's, and 6 minus 0 for the x's. That's 3 over 6, which reduces to 1/2. For the second one, we have 2, 4 and 4, 0. This being x1, y1. These being x2 and y2. So y2 minus y1 is 0 minus 4 for M. And again, these are talking about the lines down here. So line N and line M, I know it's confusing because line M in this case is also the same letter for slope, because slope is usually M. So again, 0 minus 4 is our y's here, and 4 minus 2 will be our x's. So this is -4 over 2, which reduces to -2 over 1. Looking at our two slopes, they do look like opposite reciprocals. One's positive, one's negative. One's 1 over 2 and one's 2 over 1. If we want to check this, they should multiply to give us -1. I multiply 1/2 times -2 over 1. Multiplying across, 1 times -2 is -2. 2 times 1 is regular 2, and that reduces to -1, so correct. This concludes section 3.4. This should all be review information. That's why I went through it somewhat quickly. Hopefully this is helpful when you're reviewing for a quiz or a test or for finals.